In this question, we are required to find the gradient of this function and show that it will be equal to what's given here. And in part B, we are also required to find the equation of the tangent of this curve at the given point. So I'll start with part A. So for part A, we have a quotient, so we'll apply quotient rule. So dy over dx will be equal to x plus cos x multiplied by the derivative of x cos x minus x cos x multiplied by the derivative of x plus cos x, all this over x plus cos x squared. So now, if you notice, one thing here is that here we have a function inside another function, which implies that we have to use product rule to differentiate that. So that will change our expression. So here we have x plus cos x multiplied by. Now, if we apply product rule here, we'll have x multiplied by the derivative of cos x um, plus cos x multiplied by the derivative of x minus x cos x multiplied by, now if we find the derivatives of this term by term, that will be 1 minus sine x, and then over x plus cos x squared. Okay, the next step is we'll have to differentiate this, so this will be x plus cos x multiplied by x. So the derivative of cos x is negative sine x. So basically this will be equal to negative x sine x plus cos x, because derivative of x is just 1, minus, we can expand this now, so that will be equal to x cos x cos x plus x cos x sine x, and then all this over x plus cos x squared. We can FOIL this, yeah, FOIL the first two terms here, this one and this one. So that will be equal to negative x squared sine x plus x cos x minus x sine x cos x plus cos x squared, and then we have minus x cos x plus x cos x sine x, and all this over x plus cos x squared. So one thing that will happen is that few things will cancel. So this will cancel with that, and then this will cancel with that. So what we shall be left with will be, so this will be dy over dx, which is the gradient function, will be negative x squared sine x plus cos x squared over x plus cos x squared. Okay, so that's part A. Now for part B, we want to find the gradient of this function at x is equals to pi over 2. So at x is equal to pi over 2, we shall find the gradient of this function, which is same as the gradient of the tangent, and then we use that to find the equation of the tangent as required. So at x is equals to pi over 2, the gradient of the tangent, or the gradient of the curve, can be found by plugging pi over 2 in the gradient function. So that will be equal to negative pi over 2 squared sine pi over 2 plus cosine of pi over 2 squared over pi over 2 plus cos pi over 2 all this squared. Now, one thing that you have to note here is that sine pi over 2, which is same as sine 90, is 1, and cos pi over 2 is same as cos 90. Cos 90 is 0. So this means that this will be equal to negative pi over 2 squared multiplied by 1 plus 0 over pi over 2 plus 0 squared, and this will be equal to negative pi over 2 squared over pi over 2 squared. This is negative. This cancels, so this will be equal to negative 1. So what that means is that the gradient of this tangent at or the gradient of the tangent at x equals to negative x is equals to pi over 2 will be negative 1. So we can now find the equation of the tangent. So equation of the tangent. It can be found using the point slope formula. So y minus y1 will be equal to m into x minus x1. Now our y1 is 0 and our x1 is pi over 2, and our gradient, which is m, is negative 1. So plugging those in this equation, we'll have 0 is equal to negative 1 into x minus pi over 2, which means y will be equal to negative x plus pi over 2. And that will be the required solution.